Okay, so for the first one, definitely by parts because you have two functions multiplied, where one, if you take the derivative enough, it'll go to 0, and then the other one you can integrate as many times as you need. Okay, and then this is a, this is by parts, but this one you can do tabular for. Okay, so just take derivative. Okay, the other one we'll take integral. You can even do u sub if you need, but y'all are good at this. I'll put it like that. Okay, and then, oops. Okay, then this is plus, minus, plus, as far as multiplying. Okay, so this is, and then, you'll multiply this by that, by that, by that, and that's it. So just two terms. Okay, and then, so the answer is, we'll write it as x over 2. Oops, let me do it this way. X over 2 times sine 2x, and then plus because you have like minus a negative. So that'll be plus 4th 2x, and then plus c since it's indefinite. Okay, so next one. Okay, so another tabular because the function on the left, x squared, will go to 0 if you take derivative enough times. And then e to the negative 3x you can integrate as many times you need. Derivative, 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 integral, integral, integral. Okay, so plus, minus, plus. Okay, and so we're multiplying that and that, that and that, and then that and that. Okay, so this will be negative x squared 3 Okay, that'll be, next one will be a minus, since you have minus a negative, or minus a positive, I mean. Write it as 2x over 9. And then last one's minus. Okay, next one. Okay, definitely the technique is partial fractions because really definitely because since the bottom is factorable into linear factors, and I guess that's the main reason. Okay, so this is the one where you'll factor the bottom. We'll do like some scratch work. Let's do it this way. Okay, and then we'll say the numerator of the first one equals, gets multiplied by x plus 1, b gets multiplied by x, because all we're doing is really adding the fractions on the left, and then setting the numerators equal to each other. So it'd be 1 equals a, 1, whoops. Okay, and then this will do the for x equals -1 and for x equals 0, just the values that make the different factors 0. And then we'll plug it into each one. So if you plug in -1, you get 1 equals -b. So b is -1. And then if you plug in 0, you get 1 equals a. So a is 1. Okay. Okay, so really what we're integrating is 1 over x minus 1 over x plus 1. Okay, and then we just integrate that, so that's just ln absolute value x minus ln absolute value x plus 1. Okay, and then, you know, anytime you have these logs that are added or subtracted, you can always just condense them, just like you did in Algebra 2 or Pre-Cal when you did condensing and expanding. You can just condense it into one, like that. Okay. Okay, but really either one of these would be perfectly fine, I think. But the bottom one, this one here, the condensed one, will be probably the answer that you'll see in a multiple choice, or possibly at least. Okay, next one. Okay, this is a special case of integration by parts. So, yes, this is a special case where, oh, and someone asked, I think we can do tabular for this one. Here, I never tried it. I'm gonna try it right now. I think it'll work out. Okay, we'll kind of have to, actually I think it'll work out. We'll just have to do something weird for the last integration. Okay, so this is definitely by parts though, and you know, this is really when you do this special case, and this is a case where you have e to the x, or it could be e to the something times x, it could be e to the 2x or e to the -5x or something, and then times sine or cosine. So whenever you have this case, let's try tabular. I think this will work. Whoops. Okay, and we'll just do it, wait, let me think. We'll do e to the x, y, so that. Yeah, we'll do it like twice. So derivative, derivative, and then integral, like that. And then we'll do integral, like that. And then the last step, you know, we won't do it here, the derivative on the left, but you know, every time all you're doing is taking the integral of the previous one. So we'll just write it like that. Okay, so now think about this. This will be, I'll kind of rewrite the whole thing now. So we're doing the integral of e to the x cosine x dx equals, still have to do the plus, minus, plus. Okay, so it'll equal e to the x sine x, and that'll really be plus, since it's minus a negative, plus e to the x cosine x, and this will be really minus integral of e to the x cosine x, or dx, like that. Okay, yeah, so this makes sense. And then now, notice here we have something and then minus the same thing, so we can like add this to both to both sides. Okay, and those cancel. And we get on the left-hand side, we get 2. And then just divide by 2. So yeah, so you can do tabular. Good to know. I think someone asked that in class too, but okay. So next one. Okay. This will be okay. It's not U sub because if it was U sub, you would make this U, and then that would be du. Not to say it's not going to involve U sub at all, but I think that's not the main thing about this. So I think the main thing is this is like a inverse sign. Okay, so notice the bottom. You could rewrite. We'll kind of do. Let's do some scratch work off to the side. Okay, so let's just look at the bottom. So you have the square root. Oops. The square root 9 minus x to the 4th. Okay, we need, in order to be sine inverse, we need square root of 1 minus something squared. So we definitely need to pull out the 9. And then it has to be something squared also. So here, I'm going to do the squared first. So let's say we did square root of 9 minus x squared squared. Okay, so we have 9 minus something squared, but we need 1 minus something squared. Okay, so we can like factor out a 9. That makes sense. Just kind of see if you distribute the 9 to both of these, you get back that. Okay, so we have 1 minus something squared, but times this number, right? So this will have to kind of bring into this kind of this square, that kind of outermost square here. Bring this into that, but kind of multiply it by the x squared inside. So hopefully this makes sense. I'm going to use brackets. Okay, hopefully you see that. 9, this 1/9 kind of came in here. But since you know you're going to be squaring whatever comes in here to get it out, then you have to like square root this. Square this root this 1/9 to be a 1/3, and then you can bring it inside. Okay, and then just notice, let me finish. And then just notice if you square this, you get x squared over, you get x to the 4th over 9, which is really what this is, x to the 4th over 9. So you get the same thing. Okay, and then now we'll bring this 9 out, and it'll come out as a 3. So now we have it just like we want. Okay, and then, so now, basically we're just rewriting this. Like that. And then we can do u sub, make u equal square root 3. Okay, and then so I'm gonna do kind of a weird thing. I'm gonna multiply both sides by 2. 2 du equals 4/3 x, because that's really what you have on the outside. You have like a 4/3 x, really dx. I should have a dx here. So notice everything on the outside is 4/3 dx. So now for us, when we change it to use, everything on the outside will be just 2 du, since that's what 4/3 x dx. You know, both those need to be on the outside. Okay, so now when we do u sub, it'll really just be a 2 du all over square root 1 minus u squared. Okay, make sure that's right. Yeah, okay, that's right. Okay, then we integrate. So this is inverse sine. And then u is x cubed over 3. And that's it. Or x squared over 3. Whoops. Plus c. Okay. Okay, sorry, I'm just gonna make sure that's right. 4/3. Oh yeah. Okay. Okay, next one. You know, should see this is inverse tan. It's not factorable, so you can't do the partial fractions, the a and b thing. It's not completing the square because you need an x term in order to do that. Wait, do you? Yeah, you do. And then yeah, so this will be an inverse tan type of question. Okay, we'll pull out the 16 from the bottom. And I'm just going to kind of do it all at once. So hopefully this makes sense. 16 times 1 plus, and this will really be like x over 4 squared. Actually, no, I'm going to do it in steps. Sorry. Do this in steps. Oops. This is like 1 over 16 x squared. Okay, then that's how it becomes. Pull out a 1 over 16. Okay, and then 1 over 16 times x squared is really 1 over 4, the whole thing squared. Okay, and then now we can do different thing. You know, we could do u sub now. Make u equal to x over 4. So du will be 1/4 dx. Okay, and then when we substitute, we get 1/16 integral. So the dx, okay, and this will really be 4 dx, or sorry, 4 du equals dx. Okay, so that dx will become 4 du. Okay, and then the 4 and the 16 will cancel to be 1 and 4. So now this is just 1/4 tan inverse u plus c. Okay, and then u is x over 4, so it's that. Oops. Okay, that's everything on that page. Okay, so this next one, oops. So definitely a completing the square and then inverse sine. So, and that's real typical. Like completing the square will be kind of the initial form, you know, changing the initial form, and then from there you'll use some other technique. Yeah, it just depends. Maybe inverse sine or tan, maybe ln, maybe something else. So, okay, so we'll just do scratch work off to the side. I think you don't have to, but I'm gonna rewrite it to start with. So negative x squared plus 16. Pull out the negative from the first two terms. Okay, so yeah, so whatever's here, a number or negative, you always pull it out, even if it doesn't go in evenly into this. So that's what we do. Pull out the negative from both of these. You don't have to pull it out from the last term. Last term, just put on the outside like that. And then, so remember, what goes here is half of this squared. So half of 6 is 3. 3 squared is 9. Okay, but you putting a 9 in here is you really adding a negative 9. So then you have to add a positive 9 to cancel it out. Okay, and then this becomes negative x plus 3 squared, and x plus 3, because it's always the number that goes in here with x is always half of the number that's multiplied by x in the previous step. Okay, this will be plus 25. Okay, since this is going to be inverse sine, you know, this is the thing that's underneath the square root in the original. Really like switch those. And then just like in the kind of previous ones, we'll pull out because we need a 1 minus something squared. And we know, you know, we're really going to divide this by 25 or times this by 1 over 25, but then it'll come in the square as a 1 over 5. This will really be x plus 3 over 5 squared, like that. Okay, so hopefully that makes sense. Okay, so this whole thing is going underneath the square root. So I'm even going to pull out the 25 from the square root, and it'll come out as a 5 in the bottom, which will really be a 1/5 from the whole thing. Okay. Okay, then we can do u sub. Okay, then we substitute. Okay, that dx becomes a 5 du. Bottom becomes a 1 minus square root. Oh, this should be a square root. Whoops. Yeah, that should be a square root there. Okay. And then now the 5s cancel. So this really just ends up being inverse sine exactly of u. just put that u back, the x's. And that's it. Okay, real common, real common that. Actually, never mind. Okay. So next one, the degree on the top is bigger than the degree on the bottom, so that we'll do long division. And then this one we can do synthetic division because the bottom is x plus or minus a number. Okay, so I'll do synthetic division. So whatever makes the bottom 0, put that on the outside, so the opposite of the number that's with x. We'll do this. Okay, and then remember, you do coefficient. Coefficient of x squared is 1. That's how you got that 1. There's no x term, so you put a 0, and then there's a 2. Okay, and then you bring down the first one. And then every new number that comes down here, multiply it by -2 and put it diagonal. -2, and then every new number that comes here in the middle column, just add these two, and that's what goes here. Okay, multiply that by -2, add. Okay, so now our new integral becomes integral of x minus 2 plus 6 all over the divisor. Okay, so that's just -2. That's the coefficient of x. If there were more numbers, the next number would be coefficient of x squared, coefficient of x cubed, and so on. Okay, and then this number is the remainder, the number farthest to the right, and that always gets divided by the divisor, that original divisor. Okay, so now just integrate. And then y'all are good at these. Okay, so this one's hard to tell from the start. This one ends up not being factorable, but if it was factorable, you could do partial fractions, but since it's not factorable, we'll do completing the square. Okay, so let's do that off to the side. Pull out a 2. Actually, let's pull out a 2 first, just to see that it's not factorable. Right, so not factorable because there's no there aren't two numbers that multiply to be 13 and add up to be -6. So okay, so now we can't do it that way. So we'll do completing the square. Done. Okay, half of 6 squared is 9. Okay, adding a 9 is really adding a 18. 2 times 9, so we'll minus 18. Okay, then we'll complete the square. Okay. Okay, so this will end up being an inverse tan. Hopefully you see that because it's like something squared plus something, and we can always make this a 1. You know, we can factor out an 8. Maybe that'll be our next step. I'm going to kind of rearrange these just to see it like we're used to seeing it. So this will be like 8 plus. You know, you don't have to, but. Okay, and then we'll factor out an 8. And that 1/4 will come inside the squared parentheses as an over 2. Right? When you square that, that becomes 1/4. And then the x minus 3 goes on top. Okay, so now that's perfect. So now we can pull out the 1/8. The 8's on the bottom. Okay, if we want, we can do u sub. Okay, these cancel. And then you just get 1/4 tan inverse u. Okay, next one. This one's kind of tricky. So I'm just gonna kind of do it, and then we'll kind of look back on it and see why I did it that way. So yeah, I'm just gonna kind of do it, and we'll see. So we'll just kind of do scratch work. So then we can do sine squared, and then we can change that cosine to the 5th to cosine to the 4th. Actually, no. No, here I'm going to do it this way, right from the start. We can change it to cosine squared squared times cosine. Okay, so think about it. This is really cosine to the 4th times cosine is cosine to the 5th, and so that's the same thing. Okay, and then think about, we could rewrite cosine squared as 1 minus sine squared using Pythagorean identities. So we can say sine squared theta times 1 minus sine squared. Okay, and we'll see why we want this little cosine hanging out there. Because that's going to be kind of the result of a chain rule, because the rest will just be sines. Here we'll see in a second. So we're going to do 2 steps. We'll FOIL this out, and then we'll distribute the sine squared to whatever that is. Okay, so we squared out that binomial, then we'll distribute the sine squared. Okay, so now we can kind of just do a u sub for the whole thing. Actually, I never really thought about doing it this way, but so we could just right away, you know, I kind of thought of it as like splitting it up, but you could just do u sub, make u sine theta, and then du cosine theta d theta, right? Because if we're doing this integral, this has a d theta. So now we can replace all these signs with u's. So this will be u squared, u to the 4th, u to the 6th, and this just becomes du on the outside. So let's do that over here. And then now we just have these power rules. the others, but it doesn't matter. Did it all one fraction with some, but okay, and then that's it. Oh, to the 7th. Okay, is that it? Yeah. Okay. Okay, so just have the improper integrals left, I think. Yeah, that's everything on that page. Okay, so easy to spot this is an improper integral because because you have the infinity in the one of the limits. So we'll just do it right away. Okay, so we'll always evaluate the integral first, plug in the limits, and then evaluate the limit. Okay, so this is going to be 4x to the 1/4. Yeah, so the limit's always the last thing to do. Okay, plug in the top limit. Okay, and then now we can, minus plug in the bottom. Now we can evaluate this. So, a to the 1/4 is basically like a to the 1/2, which is square root. This fourth root. Fourth root's almost the same thing as square root. Square root goes up really slowly, but it goes up forever. And same thing with fourth root. Same with any nth root. The bigger the root, the slower it goes, but it still just goes up forever, just crazy slowly. So since this goes up forever, then this term, when a goes to infinity, equals infinity. So you can say this equals infinity, and so it diverges. Whoops. Okay, another one easy to spot that this is a improper integral. Okay, so I'm just going to integrate it quickly. Okay, plug in the top limit. And then minus, plug in the bottom limit. So e to the 0 is 1, so it's just really minus negative half times 1 minus negative half, which is plus a half. Okay, and then when you plug in something that makes this exponent go to negative infinity, then this whole exponential goes to 0. So this whole term goes to 0, and then when you take limit of a constant, that's just the constant. Okay, so this whole thing goes to 0, and you're just left with limit of a constant, which is the constant. Okay, so you can't really integrate squared trig functions except for secant squared and cosecant squared, since that's tangent and negative cotangent. But so with these, you have to use trig identities. So I don't know if y'all remember. There was one where it was like cosine 2x, double angle formula for cosine is 2 cosine squared x minus 1. And then you can solve that for cosine squared x. You can add 1 and divide by 2. So cosine squared x is cosine 2x plus 1 over 2. Okay, so we could kind of go back to this problem. Okay, first off, we have to split it up into two limits. We'll do like limit as a approaches negative infinity. A's got to be in the bottom. And then we'll make this some number c, something like that. And then we'll use our the new expression that we got. So this is sin 2x plus 1 over 2 plus, oops, now we'll do limit. Maybe b goes to positive infinity, put the b in the top, put that same c in the bottom, and then do this cosine 2x plus 1 all over 2. Okay, so now we can integrate these. Okay, so here, let's do this. Limit. Okay, so this first term is really like, I'm going to kind of splitting it up. Actually, no, I'm going to pull out the 1/2. Actually, I'm going to pull the 1/2 out of the whole thing. Doesn't really matter, but. Pull the limit out of the 1/2, this 1/2 out of the integral, and then that can come out of the limit. Okay, and then now we just have to integrate cosine 2x, which is, maybe I shouldn't have pulled that half out, it doesn't matter, which is 1/2 sine 2x, and then integrate 1. Same thing, pull out a 1/2. It's the same integral, same antiderivative. Okay, plug in the limits. Okay, plug in c. Same thing for the other one. Okay, it's basically the same limit, or same antiderivative. Just 1/2 sine b plus b. Okay. Okay, so this will definitely diverge. Really, kind of all of these, they don't go to infinity, but they don't, these limits don't exist. So the limit so think about when this, oh wait. Well, really when the limit of this doesn't exist. Sine 2a, when a goes to negative infinity. So think about when this whole thing, when the thing inside sine, this angle or argument or whatever goes to negative infinity, this, in order for a limit to exist, it has to approach a single number. And this never approaches a number. This will be kind of adding up positive area and then the same negative area and then positive area and then the same negative area, as you go to negative infinity. And so this won't approach a number. This area is going to kind of bounce back between, I don't know, like 2 and -2 or no, wait. Yeah, I'm not sure, but it's going to bounce back and forth between two values, whatever they are, but never approach anything. So this, you can't evaluate these limits. They don't exist. So you'll say this diverges. So they don't equal infinity, but they can still diverge even if they don't equal infinity. Okay, this one hard to spot. Just have to kind of every time, especially on this quiz, but really just from now on, you're just gonna have to for every definite integral that you see, especially one that have fractions or one that can be written as fractions. Got to check to see if there's a vertical asymptote. And then that's going to be an improper integral. So, okay, so you can see when x is 1, when x is 1, which is the upper limit, the bottom 0, so there's a vertical asymptote. So we'll have to, limit x approaches 1. Let's think about this goes from 0 to 1, this interval. So we're really approaching 1. This function will be kind of doing something in between here. Who knows what. But we really want to do it as x approaches 1 from the left. Like that. Okay, and that 0 stays 0. Oh, not a. I have to change that. Or not x, I mean. Pick something like a or b or something. Okay. And then I'm going to change this to 1 minus x to the negative 1/2. Might as well do that in this step. Okay, and then we can do a power rule. Just there's going to be a negative with the chain rule, but you can just do that negative there. This is really going to be 2. That. Okay. And then do limit. Okay, then plug in that limit. We're plugging the limits of the integral. Actually, I'm going to pull out the negative 2. Okay, and plug in 0, you just get 1. Alright, and then, okay. And then, so as x approaches 1, as a approaches 1 from the left, this will approach 0, but from values less than 0, and that's necessary. If this was approaching 1 from the right, this wouldn't exist, because if this a was approaching 1 from the right, this a would be bigger than 1, which would make 1 minus that something that was negative, and you can't take square roots of negative, or it doesn't exist for real numbers. Okay, but this is approaching 1 from the left, so that's okay. Number smaller than 1, that's going to keep this positive. Okay, so this really is just going to go to 0. So this, and then just this is really just going to be negative 2 times negative 1, which is 2. Okay, so another one where if x is 4, one of the limits, and actually it could be a value in between the limits too, but in this case it's just one of the limits. Yeah, so if x is 4, there's a vertical asymptote, so we'll have to account for that. And then this technique, the anti-differentiation technique, is going to be u sub, right? Because derivative of this inside is that top part, basically. So we'll do that kind of quickly. Okay, and we'll do 4 from values less than 4, since it's between 0 and 4. just going to kind of integrate this quickly. Oh, this is to the 1/2. Actually, let me rewrite this, sorry. Okay, so I'm going to just integrate this quickly. Basically, you're going to get a half and a negative 2x, you're going to get a negative x, so just negative. Okay, I'm going to pull out that negative also, just so it doesn't, so this negative, I'm going to pull out here. Okay, plug in 0 for x, and you get 4. So you get square 16 to the 1/2, so that's 4. Okay, and then kind of same as the last thing. Yeah, so this part goes to 0. 4 values less than 4, that will be positive on the inside of that thing to the 1/2, and then just limit of negative 4 is negative 4 times that negative is just 4. Okay, and then this one, last one's a tricky one. I think I did it. I think I saw how to do it. So times top and bottom by 1 plus sign. Actually, let's just forget about this. I'm not going to give a trick identity one. And I gotta go. Okay, that's good for this.